you welcome back to the second session of the day 5 of our faculty development program. Now, it is with great pleasure that I welcome you all to the session of our faculty development program. Today, we are truly honored to have with us a distinguished academic, a visionary researcher, and a pioneer in interdisciplinary science, Dr. Diana. Dr. Philip currently serves as the adjunct professor of artificial intelligence in applied medical sciences at BCMC Trivandrum and is a visiting professor at the Indian University Center for Astronomy and Astrophysics, Pune. This expertise spans across artificial intelligence, astronomy, data science, medical research, and biodiversity, making him a well-known technological development and scientific vision. With collaborative research studies across esteemed institutions such as Cardiff University, Caltech, Harvard, Arizona State University, and the African Institute of Mathematical Sciences, Dr. Philip's work has had a global impact. He is also the Dean and Director of Artificial Intelligence Research and Intelligent Systems at Alice Labs, contributing to the development of cutting-edge AI tools in fields as diverse as astrophysics, climate forecasting, NLP, biodiversity, and cryo-electron microscopy. Dr. Philip has over 2 decades of experience and has published extensively in reputed international journals. His developments such as ATMA, DUNT, and Cortex ATMA platforms have transformed how researchers access high-performance computing for scientific applications. Today, we are privileged to gain insight from someone whose contributions continue to redefine the frontiers of interdisciplinary research. Please join me in giving a warm welcome to Dr. Diana.
A very good afternoon to all of you. So I hope that after the lunch you are all feeling a bit dizzy, but I'll make sure that you don't sleep at least. This topic that I am going to present is of great importance today, mostly because of the attempts to reduce global warming through reducing the carbon footprints. So hydrogen has become the most promising candidate for replacing carbon because of its energy content and its abundance. And global warming was debated for a long time whether it's caused by the greenhouse that we blame it for a long time, but that era has ended, and today we know that global warming is reality and is mostly caused by greenhouse gases. So reducing greenhouse gases is one of the greatest targets today. But will hydrogen do that? It's a question, because water vapor is one of the most, even stronger than carbon dioxide, global warming agents, which is the reason why when it is fluid, you feel very warm and very discomfortable. So that's the situation, but of course we need to reduce carbon footprint, and that's the purpose of this kind of innovation in hydrogen related areas. My talk will be mostly going through some of the latest developments, giving you some introduction, that's all. I won't go into the depth because it involves a lot of intense research topics and technical jargons which I do not have time to present in 2 hours. Well, with that start, let us start and let us look at hydrogen. Hydrogen is, because of its abundance and because of its necessity, is going to be one of the most important, as I mentioned, sources of energy to reduce carbon footprint. And it is known that more than 30% of the contributors of carbon footprint comes from industries like steel, cement, ammonia, etc., and heavy transport vehicles, which contributes to about 7% of the carbon deposits, then other sources of energy, like in Kerala, for example, we do not need to depend on burning fuel for producing electricity, but in most places they need to burn something like naphtha or some other carbon-based sources for getting energy. So all these things point to the importance of hydrogen and the need for hydrogen to be brought in as a candidate for replacing carbon deposits and carbon-based fuel as a source of energy. Now, the question comes, hydrogen has been here for a long time. Why now? Why it is important now? We know that the basic source, the main source for hydrogen is water. But splitting hydrogen from water requires a lot of energy, but more than the energy that can be produced by burning hydrogen. This was the reason why hydrogen, although we knew that it is a very good source of energy, was not in practical application. Now what has happened? Now we have a lot of renewable energy sources like solar energy, which is one of the examples for producing electricity. This solar energy can be used to generate hydrogen from water. Well, why should we use hydrogen then? Can't we use solar energy directly? The problem is, at night time what will we do? We need batteries or we need some energy support systems for nighttime use. But if it is hydrogen, hydrogen can be used with fuel cells to produce electricity, which can be directly used. So that is the advantage of, although there is some loss in energy, using solar energy for generating hydrogen sources. So this renewable energy has become, in fact, you know that even in Kerala, the amount of energy that is produced by renewable sources is a considerable portion of the entire energy requirement. So this is a situation, and so we have a lot of renewable energy and it is free. Once you install the solar panel, the energy comes as soon as the sun rises and it will stay for the whole day, all the daytime. Which can be used for producing hydrogen. So that is the major reason why hydrogen became so attractive. So surplus renewables, which produces green hydrogen, because there is no contamination relating to the production of hydrogen. Then there are policy drivers. Policy drivers means everybody wants to change or reduce the go to zero carbon footprint. So that is the goal here, and this reduction attempts have in fact prompted policymakers to give grant for hydrogen-related research and hydrogen development, which is also recent. Net zero mandates for companies that they should not produce any carbon-based outputs which contaminates or which makes the atmosphere impure. These conditions have in fact promoted, and which is the reason why in these days, in recent times, hydrogen development, our hydrogen-based energy sources have found a lot of application. Well, so what is a global hydrogen demand? If suppose we are going to produce hydrogen, how much hydrogen we need? And this has been projected by various studies, and the International Energy Agency, for example, estimates that there is going to be a six-fold growth in hydrogen demand by 2050. And if you look at what the demand today is, it is about 74 metric tons of hydrogen that is required today for most of the industries to replace with hydrogen, which will grow up to 528 metric tons of hydrogen by 2050. So we are projecting into the future and seeing that this is going to be the way people are going to depend on source of energy in the future. Okay. Now, when we think of, am I audible when I move around, or I have the tendency to, should I speak very close to this mic? No. You can hear me, okay. You can hear me, and the recording also will be able to. Yeah. Alright. So, one of the problems with using hydrogen is in storing the hydrogen, which is a whole topic I am going to cover today. So, storing for hydrogen is a great problem because of various reasons. The first reason is that hydrogen is very abundant, that we know, not in the atmosphere, because if it's very light, it will escape, but in the universe it is abundant. Hydrogen is a source of energy for the sun, all the stars we see, and everything in the universe started with hydrogen. So hydrogen is very abundant element throughout the universe, and it is, though it is very abundant, it is one of the most lightest elements that is known to us, because it has only one electron, one proton, and it makes the lightest element that is known to us. It is about 14 times lighter than air, which is the reason why hydrogen balloons fly up in the sky when it is left free. So that is the reason. And another issue is that if I take hydrogen, if I want to hold 1 kilogram of hydrogen, the space I will require will be about 11 square cube. Mean that if I make a cube of 11 meters in length, breadth and height, that would be the size of the area, that would be the volume which would be required to hold 1 kilogram of hydrogen. So you can imagine how much space it would require for vehicles to carry, which is the reason why we have to compress it, liquefy it, or make solid hydrogen for transport, which is the reason we need it. Okay. So we talk about different, as we go, I'll introduce all the terms that I use here. So this lightest element, hard to store. It has a low volumetric density, which means that taking a uniform volume between two things, it will be lighter than the other one. So it's low in volumetric density. High flammability, that is a very valid point, because if something explodes, the force that it exerts would be equal to the difference in the pressure between atmospheric pressure and the pressure that is generated by the source. But when hydrogen is inflated, what happens is that it reduces into a drop of water, which means that it creates vacuum. So the pressure difference would be almost equal to 1 atmosphere pressure difference, even if it is an ordinary place like this, where it inverts, it actually inverts, it reduces into water drops, and that is about 1 atmosphere pressure, which is huge. If for example, a few grams of hydrogen is inflated here, it may cause the building to break down. That much of energy, that much of force is actually generated by hydrogen when we use it. So what are the current storage methods that hydrogen uses? Current storage methods, one of them is to compress hydrogen, and compressing hydrogen can be done up to 350 or 700 bars of atmospheric pressure. So that much pressure of hydrogen can be compressed and stored in cylinders, which the problem with storing at high pressure is that it will be very difficult to safely handle it. Because a small leak, because hydrogen is so easy to evaporate, it will automatically leak out and will cause atmospheric, will cause the same kind of threat that we have been mentioning. So this is the highest pressure in which hydrogen is usually carried when hydrogen-based vehicles are using hydrogen. Then there is the cryogenic, which is a liquid hydrogen, which has a problem that it has to be kept at minus 253 degrees centigrade to remain its liquid, which is very difficult because you are saving energy by using hydrogen, and at the same time to maintain it at minus 273 degrees centigrade, it will be impossible for you to do when it is about or something. So you cannot use it like that. Now there is also another method, because if you take salt water, like the sodium chloride, for example, if you add concentrated, very saturated salt water, it is opaque to hydrogen. So you can have hydrogen at high pressure under the ground with a covering of salt water over it, and that is what we mean by salt covering. And that will be that is under experimentation, but it has been proved to be at least viable technology for getting continuous source of hydrogen. Just like you get this carbon-based petroleum and all other things from the ground, you can have hydrogen coming out naturally from it for use for the various applications. That is what people have been trying to do. Well, so the Department of Energy in the US has set some targets for hydrogen use, especially for vehicle applications, where it can be used for carrying for various applications, where in cars, in motorbikes, or in trucks. This can be used. So they have said that the minimum, this is what has been achieved when DOE was making this declaration. The minimum gravimetric means the weight percentage. If I keep hydrogen in a cylinder, the weight of the cylinder plus the weight of hydrogen. If you are most of you are ladies, you must be familiar with the kind of gas cylinders we use. You say that it is 14 kilos with the weight of the gas and also the cylinder. So once the gas is taken off, it is some 12 kilos or something like that, which means 2 kilos of gas has been consumed. That is the question. But in the case of hydrogen, because it is so light, so lighter than any of the other things, you can have achieved about 5.5%. That was the target, 5.5% by weight of the cylinder that you may have hydrogen, which means that if you take 100, you will have 5.5 liters as 100 liters of 100 kilograms as the weight of the cylinder, you will be having 5.5 kilograms as the weight of the hydrogen that is contained. So that is the target, which is a minimum requirement for a vehicle to move smoothly on the road with hydrogen. So then volumetric is a volume, the amount of volume which has to be compressed to 40 grams per liter. That means 1 liter bottle is here, 1 liter of hydrogen should have, 1 liter of hydrogen in the bottle, in the container should have 40 grams of weight. So that is the criteria. Then the cost should be something like $10 per kilowatt hour. That means the energy output that we get should be 10 kilowatt. Why 10 kilowatt? $10 per kilowatt hour. Why it should be that much? Because that is comparable with the fuel, other fuel, petroleum-based fuels that we spend for getting 1 kilowatt per. So refueling is another important thing, because if you want to carry, one of the problems with battery-based cars is that if you take it along with you, charging time is much longer than the running time. So it takes a day or at least nowadays it can be charged in 3-4 hours, but it takes a longer time for the charging to happen. Same thing with the hydrogen fuel also. And so they say that filling the thing should be at least done in 3 minutes. More than that cannot be allowed. In many systems, it won't be possible to fill it up in 3 minutes because of the slow rate at which this charging, this hydrogen storage can be used. Okay. Well, there are several limitations with compressed hydrogen. One is that at high pressure, the risk is very high. And it becomes very bulky, it becomes heavy, because the containers have to be very heavy for keeping it at pressure, and infrastructure should be intensive, which means that any leakage would cause an explosion, an implosion in fact, which would be very catastrophic. So we want to avoid all these things, which is the reason why this becomes a major hurdle in developing compressed hydrogen as a fuel. Then we can think of liquid hydrogen, assuming that we are able to keep it at low temperature. Then the energy loss due to everything evaporates. Anything in the form of liquid evaporates. Because of the low temperature, hydrogen would evaporate much faster. So the liquefaction would be actually much greater. At least 30% is lost in when you liquefy hydrogen and when you use it for some other fueling purpose. So whatever you produce, 30% will be automatically lost due to the liquefaction process. This is called boiling of loss, and that happens. And cryogenic handling is hazardous. See, suppose I take liquid hydrogen, it is minus 253 degrees, and if I accidentally touch it, my cells will turn into glass, and it will be necessary to amputate it. There is no way to heal it. So it's very hazardous to use liquid hydrogen and cryogenic. You have a question? No. Okay. So that is one of the major hurdles for using liquid hydrogen. It is much difficult to handle it. It's very hazardous. Okay. Now we come to solid state hydrogen. What is solid state hydrogen? Solid state hydrogen means we keep hydrogen between materials. So if you have some water spill over here, what you will do is that you take a sponge and take it out. And likewise, if some materials, some metals or some alloys can hold hydrogen inside it, and which is what you can use for storing hydrogen. So this is the idea in solid hydrogen, solid state hydrogen. Solid state hydrogen does not mean that you are solidifying hydrogen, you are actually transferring hydrogen to solid materials. So it is safer, it is denser, and it is lighter, because most of these solids are carbon based or some magnesium or some other substances which are lightweight, so it is lighter and better suited for mobile and grid applications because it can be carried around. What happens is that it will absorb hydrogen at a particular temperature, and slightly changing the temperature will release hydrogen. So you can absorb just like a sponge. You use a sponge to drain water, and by squishing it you will be able to release the water like that. Okay. So what is solid state storage? There are two terms which are commonly used. One is called the absorption, which uses metal hydrides and complex hydrides for storing hydrogen. And what happens in absorption is that in crystalline structure, between the lattice, hydrogen goes and sits there, so that it will be available inside the material, and by heating it up, you will be able to release it from there. So that is what is meant by absorption. And absorption means on the surface itself, hydrogen gets stored. You see, just like water. If I touch my hand in water, it will get adhered to my hands. So similarly, the absorption means this hydrogen will get attached to the surface. So what is the way to do it? You increase the surface area. So how can you do it? You go to diameter. So these are all connected areas which will be able to do a lot of things. So nanostructures are mostly used for this kind of applications. This I mentioned. Advantages of solid state storage are lower pressure for so it is safer, and higher volumetric density. And when I mentioned about the DOE criteria, they said that it should be at least 5.5 per weight of the hydrogen that it can carry. But using solid state, we are able to go up to 9 weight, which means almost twice the capacity can be handled. Then it is reversible hydrogen release. That means heating it up will release hydrogen, cooling it will absorb hydrogen. So it can be the amount of, depending upon the amount of hydrogen you require, you can slightly heat it up or cool it down to regulate the flow of hydrogen, just like the accelerator on your car. This is just by controlling it is electrically controlled by heating up or releasing. You will be able to control the flow of hydrogen. Well, there are several challenges here. One of the challenges is the poor kinetics. Kinetics means the speed with which hydrogen is absorbed and released from the material. Hydrogen won't get easily absorbed or easily released just by changing the temperature. You need to add a lot of catalysts, you need to add a lot of things, and which is where the area of research is going. High dispersion temperature, which means hydrogen has to be released. If hydrogen is absorbed in a material, to release it, you need to give a lot of energy, a lot of heating to it, which is one of the limitations, which is something that people have been trying to resolve in this area. Then the gravimetric capacity, that means again the weight, how much of hydrogen it can contain. Then the other term is material degradation. Material degradation means just like using a sponge. You cannot use a sponge for your lifetime. You have to replace it. Likewise, it also gets degraded as the structures also get degraded as time progresses, and which is one of the limitations. There are certain performance matrices that are used just to evaluate. These matrices are used to evaluate how the different candidates, different methods work. So capacity, that is how much of weight percentage it can handle, that is one criteria. Kinetics, which is how fast it is charging and discharging hydrogen, that can be used as another term. Thermodynamics, that is the temperature at which these things happen, and cyclability and stability, how many times it can store and how many times it can release. These are the major performance metrics that are set as standards for comparing two methods. See, I am just giving you an overview of all these things just to make you familiar with the context in which we are going to discuss all this. Okay. So the problem is that no known material meets all the ideal criteria. That's known for anything, not just for hydrogen, but for everything. You won't have one candidate which is satisfying all the conditions. So one of the most difficult things here is to explore all the elements and the combinations and the methanolics and all those things, hydrates and all those things, for finding which would be a suitable candidate. And this is really huge design problem, and it would take years and years for material scientists to find out a suitable platform that can do the desired kind of outcome. Okay. So current material classes, metal hydrides and magnesium hydrides are most known and most popular for hydrogen absorption and dispersal. So that is one of the most common thing. But the problem is that magnesium hydrides, until recently, when an alloy was found, until recently this had no capacity and long time for charging. All these kind of kinetics were very slow. And there are other hydrides also. For example, ionides represent aluminum-based hydrides, and borohydrides are boron-based hydrides. These are used. Then this metal, organic frameworks, and of course, ceramics and graphene-based structures. All these things, graphene of course comes, you know where it comes from. So all these are being explored and experimented, and these are some of the candidates which are most commonly used today for hydrogen storage. Well, there is always a trade-off with most of these methods because of the way in which they are developed mostly. When capacity increases, that means the amount of hydrogen it can store, the capacity increases, its stability decreases. And when stability increases, its speed with which it can absorb or dispose hydrogen decreases. So all these things are related. So it is a multi-objective optimization problem which we need to consider. How many of you have some physics background? Okay, very good. So you know what happens when many body problems are considered. See, if you have only two bodies, you can very easily write the equation for that. If you have three bodies or more than that, it becomes very difficult for the equations to be analytically so. Same kind of situation happens here also, which is so therefore a very challenging problem to optimize in multiple criteria. So this is where AI can help. AI can help in rapid metal screening because AI works very fast, and I need not have to tell you, you must have all used ChatGPT and you know how fast they respond to your questions. So that kind of things are possible, and you must remember that all people are using it, and even then it is able to do it at that speed. So it is able, if it is a dedicated job, it will be able to do it much faster than humans can do, and that is the reason why AI becomes a significant, plays a significant role in this platform. Then AI can make predictive models. Predictive models means you know that a particular, for example, magnesium hydrides, you know that it is good for storing hydrogen. And AI models can predict which other combinations could be favoring the similar situation when you want to produce, when you want to use them as solid-state devices for storing hydrogen. So this kind of predictivity is one of the advantages of using AI-based techniques. Then pattern discovery. Pattern discovery means what kind of patterns are favoring a particular situation. Because in a crystal or in a material, the atoms are arranged in a particular fashion, and it is the gas in between them, it's the potential energy between them, or it is the electronegativity or electropositivity in them that is attracting hydrogen to get and stick to it. So all these things would be can be predicted with AI-based models, and we'll see some examples later. So the research momentum has been mostly driven by AI-guided discovery of magnesium titanium hydrides. So I mentioned that magnesium hydrides are very good. Then AI suggested that if you use titanium as a catalyst, then it will help you better improve the case. And in fact, it could in fact predict about 10 raised to 6 different combinations of this titanium can be added as a catalyst into it, and where it should be added, which molecule should be closer to it. All these things will decide how much of hydrogen can go. So that's why the AI model or the machine learning model could do all this computation and come up with something that could be able to do it much faster. Much faster means it produces models. Okay. It was able to come up with a very suitable solution which was able to almost twice the amount of by weight the material the hydrogen could be stored in the material. Then there is a totally different kind of model which is called generative models. Generative models can be used for designing this metal organic frameworks of materials. We'll see them later. But what is the advantage? What is generative models? Generative models are AI models which are able to generate molecules. And one example you are familiar is the fake images that are available. See, all these fake images are generated by generative AI models. Likewise, just like generating this fake images, molecules can also be generated. So various combinations of molecules would be experimented, and crystalline structures would be experimented, and the AI model will be able to generate which kind of models would be best suited for the particular application. Okay, it also brings in a lot of opportunity for researchers and students. It's safer, scalable, and efficient. And it's aligned with 2050 goals. So if you do research today, if you work in this area today, the future will be much better than working in any other area. And it requires interdisciplinary R&D, means that you need to know chemistry, you need to know physics, and you need to know how to do all the computing things using AI and Python and all of the tools. So this platform is requiring a lot of interdisciplinary research and activity, so there is a lot of opportunity also based on what it can give. So this has brought in a paradigm shift in our research models, and nowadays, although we always think of chemistry lab as a lab where you have test tubes, you have chemicals, and you have all other sort of things. Today, the modern chemistry labs don't have even chemicals. Everything is synthesized by the computer and is done there. So it has brought in a paradigm shift in the whole technology. Well, why and how this helps? It's about 100% faster screening than traditional methods, meaning that if you go to a lab, take a mixture, prepare a mixture, it should be very carefully done, titration and all other things of procedures are there. Those can be easily overcome using synthetic molecules which can be generated by AI models. So it is at least 100% faster than traditional methods. It's predictive accuracy that is advantage. See, making a prediction is easy, but the accuracy in the prediction is much more important. If I say that it will rain today, it should rain today. Otherwise, it's meaningless. So likewise, the predictive accuracy with the AI models for the molecules that it has designed are more than 90%, which is really good. Because in the lab, you have to spend years together and you have to spend a lot of time to get one of the things that you can obtain with this. And it can do multi-objective optimization, which is what we have been discussing. Because AI models are mathematical models, you can incorporate all these things. Or physical models, they are physical models, all these things can be incorporated. So these are the abilities. Now how it works? This is just a flow diagram showing how it works. So you have data collection. Data is the most important thing. Data means what you give as input to the network, to your model, and that decides what the quality of the output would be. It's just like learning. The kind of textbook you use for studying decides what kind of output you can get. Or the kind of papers you read, or research papers or whatever that you read, or the kind of courses you go in, kind of teacher you go through, all these things decides how much the outcome would be. So likewise, data is the most important thing and most difficult thing to obtain also. So data collection is the first step. Then what you do is that you do a feature engineering. Feature engineering means you extract parameters from it. For example, the bond length, the bond strength, what kind of elements go in, all these things are inputs to the all these things are to be extracted from the data. So if you take a molecule or a crystal, you have to know the lattice structure, all those things you need to know. Then what you do is that you train the model on that. So your feature engineered data comes for the training, and you can use different kind of machine learning tools like graph neural networks, random forests, and transformers. These are the most popular ones I put in there. I'll explain what they mean. And then what you do is that the machine will train on available data, and it will make some predictions. And these predictions, it will grade them with priority, saying that this is the most likely candidate, this is the second likely, third likely, like that. And we can go to the lab, synthesize it, and see whether what the machine says is true or not. And when I say that it is 90% accurate, there is a 90% chance that you will get the right candidate with the prediction. So this is very good, and that is the reason why AI has become one of the major contributors for hydrogen-based solid-state discovery. And in many of the areas of material science, AI has infiltrated. For example, we do a collaboration with the National Chemical Laboratory in Pune, and there I met a professor who has never gone to the chemistry lab for doing any of the experiment. And National Chemical Laboratory of India, which is a prime institute, the chemistry teacher, the professor told me that she has, it's a lady, she has never been to a lab. She has always sat before the computer and done everything. And she has very good publications in many of the leading journals, which is the reason why she is at MC. Otherwise she won't be there. Okay, so that is the kind of power that machine learning motors. Okay. Now, I mentioned that data is the most important thing, and data is the most scarce thing to obtain. Data scarcity can also be handled with the aid of AI, because data won't be easily available. Machines will have to search for data and get it. For example, in publications, if you look at the material science publications, they would say this has been done, but they will provide you the data. They just say I have added this thing or I have done this and got this result, but that is going to the publication. But if you look at all the papers, less than 5% share the data. So that is the main problem. And published studies require complete data sets. Okay. So there is a technique called NLP, Natural Language Processing, which is a technique that ChatGPT uses. NLP extracts data from papers. So what NLP does is that although there is only 5% of the papers have publication, it will search through all the literature to find this 5%, just like searching for a needle in a browser. It will do that, and it will just pick up those data and provide it. So that is, there are tools available for that. I have just given MaxI Bot. Bot is it's a Google product which is able to, they have developed something for material science. So material science Bot can be used for extracting from journal literature purpose which has this kind of information. So it can be used for other, not just for material science, this is focusing material science, but can do in other literature survey also. So if you are a researcher, how many of you are PhD students? 2, 3, okay, good. So if you are going for a literature survey, if you don't get the time to read all the book, just go to Gemini, for example. Upload a book, you need a license, so that can be obtained. your coach can your research lab can get it. And if you upload a book, it will summarize, and it will ask, if you ask questions, it will answer what that book says about that particular book. So this kind of things can, in fact, accelerate the research at a much cost effective. When I was doing my PhD some 30 years ago in Cochin University has the rarest privilege of having internet connectivity. And of course, my research lab also had internet connectivity. In fact, we got the first internet connection in Kerala, thanks to the association with the Inter-University Center for Astronomy and Astrophysics in Pune. So what I am trying to say is that there you get all the research publications, the titles of the papers on a floppy disk if you do the floppy disk. So that was a kind of hurdles one has to go through in those days to read papers, because you cannot afford many of the latest journals, which are very expensive, physical reviews and all the journals, which are very expensive, so you cannot afford them. This was the only thing that was available. Now it is available on the fingertip. On your mobile itself, you have all these applications which can tell you in the system. So it's a right time to do research, and of course, BERT and NLP, natural language processing, will help you a lot. Okay. Then there is something called data augmentation. Data augmentation means, suppose I get a data. This data augmentation is greatly used in other areas of machine learning also. Where, for example, if I get 3-4 photos of mine and upload it to Google, whenever it sees my picture, it will say, "Oh, this is that person," or "This is this person." How Google is able to do that? It is able to generate images based on what it has been given. So it will synthesize and compare and find out, oh, this person. It will first look at all my contacts. Then I try to identify how each contacts differ from each other. And based on that, they will say, oh, this picture belongs to this person, this picture belongs to this person, like that. So they can do data augmentation. Data augmentation is a technique which we also use when data scarcity is there. You have a particular question, you just orient or you just change the molecular length or all these things and see what happens and provide that as an input to the system. So data augmentation is done. Then there is something called active learning. Active learning has recently become very popular, although this was one of the topics that was discussed 30 years before in our research, in my research thesis. Active learning means, instead of, say, usually what machine learning people do is that they take a random data set for training and you test on the remaining data set. When data is scarce, what happens is that this random pick may not be a clear representative of the entire system. See, it's just like if you look at all the fake images that are produced, you see that most of the fake images are of white people. Why is it like that? Because this training data was mostly whites. Nobody gave training data nobody from India gave training data for training, nobody from the African countries gave data for training. So all these images are, especially of celebrities, all of them are white images of the white people. So that kind of biases can enter into machine learning, and this can be handled only if we use active learning. Active learning means you take a data, you predict on it, you used to train on it, and then you make a prediction, and you check it on the entire data available, find out where it fails, pick up data from there, add to a training data, and repeatedly do it until you cover the entire scenario. So that kind of active learning is one of the most popular methods today used for machine learning. Well, yeah, here again, model's performance is evaluated by certain criteria. The performance is mainly decided by these three criteria: the capacity to hold hydrogen. So it is that number R square or R2 is a number that is given. The larger the value, if it is close to 1, that means it is 100% able to absorb. Something of 0.95 has been achieved by all these AI models. So that is a capacity. And disruption, that's a temperature at which hydrogen would be released, and it has been, the predictions have seen an error of just 15 degrees different from the actual situation and the previous situation. The reason for that is the model is using a physics law in thermodynamics, which is called the, I'm not sure whether you are familiar with it, it's called the DFT theory in quantum mechanics. Okay. Don't worry about that, but that has some limitation. Quantum mechanics has its own inherent limitations because of some uncertainty about this, which is producing the 15-degree error in the prediction. But that is good enough because 15 degree is always adjustable. You can heat it 15 degree more or you can cool it 15 degree more. And cycle life means how many times you can do recycle. And this has given 85% accuracy, which is very good because if you develop something in the lab and if you test it for its cycle life, which can be something like 2 years or 1,000 cycles, it will take a long time. And most of the material science people, how many people are from material science background here? Okay, material science people who do nano and all those things know that testing is the greatest hurdle they have. So they want to publish something, they need to do all this testing, and when by the time it is to be produced, somebody else must have come up with a paper. So your whole work will become ruined by that. So this kind of challenges are. Well, case study for this predictor, I mentioned about magnesium hydride with titanium, and vanadium is the leader. Hydrides have 6.5 weights per capacity, which is much more than the DOE standard, 5.5. This was predicted by the machine learning tool, and this was found to be true. Well, this is how traditional method compared with the machine learning method. Traditional method of the metal organic failures, MOF, were having a capacity of about 5 weights percentage, but when AI models came up with the same thing, it was able to give about 9.8 weights percent, almost double the value. Surface area was much lesser for the stability was here it was 100 cycles, whereas it was 500 cycles for the AI-based model. And designing time was 2 years for this one, whereas that was 3 weeks on the AI model. So that speed and that accuracy and that predictability is what is offered by AI models, which is also recommendable. Achieve. Well, using the machine learning models, they have been able to design and develop about 50,000 different modes for hydrogen steroids. 12% exceeded 2030 expectations. So, see that is a see you are overshooting the target. You are having 12% more than it's only 2025, and you have already closed 2030 targets. For example, this MOF 9501 is 9.8, and it can work at 25 degrees, which is the room temperature. So you do not have to heat it much, you just need to cool it and keep it in your car, and as and when you need hydrogen, it will be releasing. So another important aspect or another important advantage of using AI is that it produces a 90% reduction in trial batches, because we can do trials by changing all these things on the computer much faster than doing it in the lab. In the lab, you have to prepare all this, each element and each component and each combination manually, whereas on the machine it can be all done very fast. So there is a 90% at least reduction in the development time. Some images can be obtained directly because you have the structure. Some will, you know what some is, right? Some will give you the structure or the orientation of the molecules, atoms in the molecule, and that will scan electron microscope. So that will, can be done directly on the images because you are actually synthesizing the molecule. You know what is some structure is. So that is another advantage. Okay, bare meaning parameter estimation, because all these parameters are estimated usually manually by doing computation after developing the crystal. Here you are manufacturing the crystal by giving the parameters. So you have all the parameters and you can always have it. So this is just an example. From 48 hours to 6 hours, the synthesis could be reduced, which is remarkable in chemistry for synthesis applications. Another very attractive and very promising candidate in AI is called the digital twin. Digital twin means you know what a twin brother is. Twin brother is, or identical twin brother means it looks exactly like the other person. So likewise, you can have a twin of the big industry, meaning that if you have a system that produces hydrogen and it is to be maintained at a very stringent conditions, which would decide what pressure, what catalyst, and how much of it should be produced, and what is the pressure, average pressure that can be safely handled. All these things can be produced on the computer itself, so that you can have sensors, IoT devices, Internet of Things. IoT devices can be used to connect your computer, and all these things can be monitored here, and the machine will tell you much ahead of time when the system should be shut down, or what kind of improvement can be done to the system so that the yield can be maximized safely. So that is what digital twins do. So it allows us to scale up things. So AI-based digital twins are also very powerful, and digital twins are used nowadays for many things, even for traffic control. For example, if you go through the roads, see, most places, and not only here, but in most places, you find that the traffic jams are always there. But using digital twin, you will be able to control them automatically. No police person has to be on the road. It can be automatically controlled. They will monitor the traffic and arrange the traffic in such a way that, or deviate the traffic do it assist to a large extent. When you use Google Map, you find that it suggests you some routes, which is going to be, it would say you will save 30 seconds or 40 seconds like that. There is even that accuracy it is able to predict. Okay. So in bioproduction, digital twins were able to show that there are 98% batch consistency. Batch consistency means different batches of data when it comes. The consistency with which it is able to handle it is up to 98%, almost close to 100%. They can do well in reactor simulations. Where I mentioned, if it is a factory where hydrogen is developed, it can be used for that. Then material degradation models, it can tell you which are the parts in a, for example, if you are working in a mechanical system, it can tell you which bearing is requiring replacement. In your car, it can tell you which oil is to be replaced, or what is the optimal way in which the car should be driven on this road. All these things, this digital twin are able to do. So material degradation is one very important aspect, which tells you how much the material has degraded over time and when it has to be replaced. Usually by trial and error, the technician knows when it is to be replaced, and he just removes it and puts in a new one without verifying whether it was time for doing it or it is too late to do it. So these kind of issues can be easily handled by these digital twins. Process optimization. So the process can be optimized, that means the yield can be maximized. It will tell you that you can increase the pressure of this particular component that is going in by this much factor, so that you will get a better yield. And this is being used largely in industry because of its high power. Everybody wants to have maximum yield with minimum loss, and wastage should also be minimized. For all those things, digital twins are very useful. I am trying to give you an overall picture so that you will be able to explore whatever area in which you want to explore it. Well, this is an example of safety. So in the case of titanium hydrides, what happens is that it is very explosive. Even exposure to air or any other particular, if the temperature or the pressure is changed, it can explode. And there are several things like this. For example, many of the petroleum products that you produce, green petroleum that you produce, all these things have this kind of DME may be known to you. So all these things have high risk, and digital twins are able to predict even 100 cycles ahead of that actual happening of the calamity that this will happen. And this is very much important, especially when you are dealing with nuclear reactions. Nuclear reactions, you need to know for safety's sake when it is safe to handle it and when it is time to shut it down. So all these things can be monitored and taken care of by database. Anomaly detection. Anomaly detection is if you are handling hydrogen, for example, leakage of hydrogen is an anomaly. It is not expected to happen, but it is happening. So that can be detected with high accuracy, and 99.7% accuracy detection is possible with AI tools, which is usually not possible with humans. Humans would realize that some leaking has happened only after the inversion has happened. So that is one of the greatest safety measures we can offer. Degradation forecasting. Forecasting is we are saying ahead of time that this is degrading, you should replace it. It will give you the warning, this part has to be replaced much before it actually breaks down. So that is the kind of hazard prediction. Prediction and forecasting are slightly different. Forecasting is something that has not happened. Prediction is something that is going to happen. So forecasting can take can be removed, but prediction hazards is going to happen. So if you continue like this, this is going to happen. So that kind of predictions can be made also. So these are detection, forecasting, and prediction are three areas in which AI models have much more perform much better than any other. Then cost estimation. Reduce cost of production. $10 per kilogram of hydrogen was the target. It has reduced it to $1 per kilogram. So that much of reduction in cost of production hydrogen could be made. Which is the reason why everyone is now moving to hydrogen. Most vehicles are moving to hydrogen, and we have even trains running on hydrogen. So all these things are happening because the cost could be reduced to much lower than what was anticipated or what was targeted. Well, then one of the ways in which cost could be reduced was to, as I mentioned, these generative models are able to tell you which is better, which can do almost similar performance as the other one. Here you see that most of the people were using platinum for doing the synthesis, but it could reduce it with iron. So replacing one material with the other reduce the cost. Iron is a very inexpensive commodity. I'd like to have some water. So iron could be used in place of platinum, for example. So that is how it was able to reduce the cost. Then, of course, process optimization, which I mentioned. Supply chain AI. Supply chain means you want to get hydrogen without any break. If you are driving a car and you suddenly find that hydrogen is not available, you are stuck at that place. So that should not happen. So that also can be made by this kind of cost optimization techniques. Well, so the labs of the future. The labs of the future are going to be AI-driven labs, and AI-driven labs of the future are 100% faster than experimental labs. So it's faster and less expensive also. And this is just a kind of diagram of how it would look like. There won't be any humans there. It will be just computers and robots which are handling it. There are certain very important reasons why this kind of labs are required in hydrogen and similar hazardous material handling because safety is a primary concern. So the components are self-driving labs. These are also called self-driving. You know what self-driving cars are. These are called self-driving labs, meaning that you need not have to tell it what to do. It will just keep on doing experiments. And in AI, this is a common practice. You must have heard about this deep mind systems beating the world champion in chess, beating the world champion in many other areas, games, and also a few years ago, in a very complex game called Go game, Chinese game. It was able to beat, and what the machines were doing is that there were two machines of an identical kind. They were playing between themselves, and one was trying to beat the other. So this is kind of training that is possible, and that is how it was able to find a new ways in which the game could be played so that it could beat even the world champion. it's a human. So that is a kind of things possible. Well, self-driving labs, robotic material handling, which is required because many of the compounds that you want to use are very, either they can burn or they can explode, or they may be very, some of them might be poisonous also. You cannot handle them with the kind of missile levels that you usually have. And continuous experimentation is possible. These deep mind machines were continuously beating each other, and it was running for about 6 months before it could beat the human expert. And you must have recently heard about what is it called? The protein structure was Google was able to do that. AlphaFold. AlphaFold was able to do protein structure determination from the sequence, which was something that they could do. And I don't know whether Blasen in the morning had mentioned to you about one of the work we have done in this connection, which was the synthesis of the 3-dimensional structure of protein from cryo-EM. Cryo-EM is the, I told you that if you dip your hand in liquid hydrogen, it will turn into glass. Cryo-EM is doing exactly that. If you take an organic material to the electron microscope, it will degrade. But if you dip it in liquid hydrogen, for example, it will turn into glass, so you can safely use it. And that's how the structures were modified. So all these things can be done or continuously done without stopping, so that you can find out the structure. So this AlphaFold was able to do that by looking at some sequences, small sequences of protein structures and trying to find out how they orient itself. And the machine was running for some time, learning how they find it in real life, and we were able to learn the logic and learn the physics or learn the chemistry or learn the biology that goes behind it, and we're able to correctly predict for all the molecules. It has produced billions of molecules now and structures of proteins now. All of that could be done with the technique. So there are various industries which go into hydrogen use, and this is one of today's hydrogen-based truck that they have demonstrated, which is going to use magnesium aluminum hydrides as the battery for hydrogen storage. In the sense, battery means anything that stores energy. It's going to use that, and of course we'll be using the energy coming from it for driving the battery. Well, so all things we are able to reduce the cost by 40% in cryo-based systems. So that is another company, or today is another company which is using this technique. We were able to reduce the cost by 40% in cryo-based systems. And H2Co is another company which was able to make pellets which look like this. After 85 cycles, it has degraded somewhat, and you can see the difference that is going on there. But these were all possible, novel structures were possible, novel designs were all possible with the help of AI models. So all of them were designed and then produced. But there are a lot of challenges in AI also. I need to stand here, right? I prefer to walk around and talk, but that's not possible. Okay, so AI has a lot of challenges, and one of the challenges is data scarcity. As I mentioned, there is only 5% data available all over the internet, all over publications. So that is one of the challenges. Simply because people refuse to share data, they may have a patent on that, they may have other interests, they don't want others to copy what they have done. All these things may be a reason, and data scarcity is one of the greatest limitations. Then there is a black box problem. Black box means you know that it works, but how it works you don't know. So that is a black box problem. Most of the AI tools, you know that ChatGPT answers questions, but how it does it is a really complex thing to explain even for the experts. So you have a question? How do you say that? I'll give it after feedback. Yeah, sure. So the backwards power is there, and you don't know how it works. So that is the main challenge. Then the computation cost. We have burned the whole planet. That is one of the questions that most people ask today. If you go to any of the discussions, they will say AI will burn the planet because AI is consuming a lot of energy. It's taking up more of the energy than the entire United States needs for running a machine like that. So that is the kind of energy requirement these machines have. So these are the challenges that are asked. But people have come up with solutions. When there is a challenge, when there is a problem, people have some solution for it. So the solutions are that there is something called federated learning. Federated learning means you do not have to share your data. You can keep the data with you. But we have a system which will take your data, take the data from others, take all the data that is available, keep them securely so that nobody sees your data, but can use it to train the machine. So this kind of federated learning is very popular nowadays, which is the way in which nowadays companies collaborate for do results. So their data will be their own, but the result will be and the whole process will be shared between people. Then explainable AI is another area which is AI-related area which is becoming very popular, meaning that inside of the black box you have something which tells you why I made this decision. So the machine will tell you, I made this decision because this is what you have asked for. And if you use some of the modern large language models like ChatGPT or ChatGPT, I don't know whether it tells you, but many systems, for example, DeepSeek, the Chinese product, if you run it, it will tell you, you have asked for this, so I must think of like this, and then there is a problem like this, and then it will say, I can handle it like that, and it will give you the entire explanation in 2-3 pages before it comes into a proposal. So that kind of explainability is there. Why it has made that decision? It will tell you, these are the things I have considered, these are the things I haven't considered, so you can ask it to, please consider that condition also, then it will go and do a sequence of analysis and will make the thing more transparent or explainable. And quantum computers are coming up, and Google has recently announced it. So quantum computers will be able to do much faster, much faster. Computations that took thousands of years to run on the normal GPU kind of machines that we use for high performance computing today could be done in seconds or less time than for traditional time requirement. So these are the solutions which AI will be exploring for this kind of application. Innovations. Physics-informed neural network. Physics-informed neural network means most of the time neural networks are machine learning tools. We will come to that in the second section of today. The physics-informed neural networks are usually used for physics-related problems. For example, in the chemistry problem, you know that chemistry is all based on rules. You know that hydrogen and oxygen will combine, but hydrogen and helium won't combine. All these are grammar-based things. So all these things can be learned by the machine, and physics, there is a physical reason for that. So once you know what is the reason for objects to fall in gravity, then the theory of gravity could be developed by Newton, and it could be used for explaining why the planets go around the sun, why we see only one phase of moon or things like that. All these things could be explained once a theory is understood. Same thing here also, the physics can be applied as a loss function. Loss function is something that you try to minimize the loss in the computation. Physics can be used for that, and that will help you to make the machine more physically realistic, physical systems, more realistic systems. 5GNN is a thermodynamics node for design, which is mostly used by in chemistry successes. Active learning robots, I mentioned already what active learning is. And quantum machine learning is one area which is coming up, where you are using quantum computers for machine learning, which requires an entirely different platform because the whole way in which quantum machines work is different. In this kind of computers, traditional computers, it is all binary that is used, zeros and ones. In quantum computers, you have to use different states. So you have multiple options. You have to consider all of them. So machine learning based on quantum computers are also being done. Well, AI ecosystem consists of different platforms. These platforms, if you are interested in hydrogen-related research, these are the two platforms that are very popular. One is open source, which means that everything is openly available there. You can see the literature, how they have done all these things. Hydrogen ML is the platform. Then there is also a cloud-based lab, which is different to do this. There are several industries and academia which collaborate with these platforms, and you can ask questions and they will answer questions. Well, if you are a policymaker or a researcher or an interested person, just interested there, you have different ways in which you can contribute. Standardizing the data set is one of the major challenges, which means that just organize, make sure that what you say is what you get, and all these things, standardization is required. Tax incentives, this has actually happened. Indian government also has started giving tax reduction for high-related research. That kind of initiatives can be promoted by policymakers and talent development, which is what the researchers are supposed to do. And in the EU and also in the US, there are different grants which are available. Indian government also is giving. We can approach the DOE for the grants. So what is the 2030 roadmap? In 5 years' time. Usually we plan by 5 years' time. One roadmap is that so we want to achieve all these things. 25, 27, we want to have million materials per year scanning, should be happening. 28, 30, generative design dominance should happen. Nowadays, generative AI is doing that, but you want to have a dominance in that. You should be able to design what you want. There is something called designer proteins, you must have heard. If you want a particular protein, you can design it and create it nowadays. So that kind of things are possible even in this scenario where you'll be able to have designer based. Then there should be self-optimizing materials. That means materials should be able to adapt itself as they grow. They should be able to add impurity or they should be able to add catalyst into it, which would help them to retain their life. Longevity of their life. So all these things are being targeted for impact. Well, market size is likely to grow to $130 billion by 2035. Cost reduction, 40 to 60% reduction, which will be much more less than, so you will be able to travel longer distances at a shorter cost than using petrol or conventional methods. Then it is expected that there will be about 500,000 AI-based experts will be required for doing the material science research by the next 30 years, 10 years. Call for action for researchers, contribute to open data sets because the data is the most crucial thing here. Try to sacrifice yourself by giving the data. For industry partners, partner on pilot projects and develop industry policymakers fund AI-related research activities. Well, that takes us to today. Feel free to ask questions if you are ready. I don't mind if you let me in between and ask questions. That's also possible. So at tea time also you can ask questions. Okay. So when we come back, we'll look at AI modeling for this purpose and AI modeling, how it is done and how it can be, what are the techniques, AI techniques that are used. So far we are giving the introduction and we are going around the bush. So we are actually going to enter in.
Then we shall have a tea break and we will listen to the session later.
Dura enggak? Iya, മനസ്സിലായി. എവിടെ അവസരം ഇല്ല.
എന്റെ വീട്ടിലുണ്ടായിരുന്നു.
ശരി.
അപ്പൊ ചേച്ചിയുടെ വീട്ടിലെ പോയിട്ട്
കണ്ടിട്ടുണ്ട് ലാഭം.
ചേച്ചി ഞാൻ ചോദിക്കുകയും ചെയ്തിട്ടുണ്ട് എന്താ
ശരി.
അല്ല പേര് കണ്ടപ്പോ എന്താണെന്ന് ചോദിച്ചു.
നിരാവാദം സംസാരത്തോടെ
കണ്ടിട്ടുണ്ട്. പക്ഷെ ആ സാധനമാണ് ശരിക്കും എങ്ങനെ അവരെയും കാണിക്കുന്നതിന് അവര് ചെയ്തിരിക്കുന്ന കോഡിംഗ് ആണ് ചെയ്യുന്നത്. അപ്പൊ
ലാംഗ്വേജിന്റെ ഗ്രാമർ മനസ്സിലായി കഴിയുമ്പോൾ വിഷയങ്ങളുടെ ഇൻഡിപെൻഡന്റ് ആയിട്ട് ബിഹേവ് ചെയ്യാൻ പറ്റും. നമ്മൾ ഈ എന്നെ ക്ലാസ് വരുന്നപ്പോൾ ഇതുവരെ എക്സ്പ്ലോർ ചെയ്തതാണ്. അതായത് വിചാരിച്ചതിന്റെ പ്രത്യേക യോഗ അതന്നെ ലാംഗ്വേജ് നമ്മൾ എന്തെങ്കിലും കാര്യം അതേക്കും ശ്രദ്ധിച്ചു കൊടുക്കും. വേറെ കഴിഞ്ഞിട്ടുണ്ടായിരുന്നു പറഞ്ഞു പറഞ്ഞവര് ചെയ്യുന്നത്. അതെ 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 ഇല്ലാത്ത അത് പറയുന്നത് ആ ലാംഗ്വേജ് തന്നെയാണ്. നമ്മുടെ ഇന്റലിജൻസിന് മോർ ഡിഫറെന്റ് ലാംഗ്വേജ്. നമുക്ക് സംസാരിക്കാൻ കഴിയുന്നത് സംസാരിക്കാനൊന്നും കഴിയില്ലായിരുന്നെങ്കിൽ നമ്മുടെ ഇന്റലിജൻസ് ഒത്തിരി കേൾക്കാനും സംസാരിക്കാനും കഴിയുന്നതാണ്. കാഴ്ച കൊണ്ട് നമ്മളേക്കാൾ ബെറ്ററായിട്ട് നമ്മൾ റെഫർ ചെയ്യുന്നത് ലാംഗ്വേജ് ഉണ്ടാക്കി.
Number of people discuss in our parliament, and people have to listen to the magnesium budgets and something to
Okay, because we have to have the process over before 4 o'clock, I'll try to make it before 4 o'clock. We'll go first. So A for hydrogen storage materials. So there is something called graph networks. Graph networks are a special kind of networks which are suitable for molecular studies. So in chemistry, this has found a lot of application. There is also another area in which it has found a lot of application, which is in social media. For example, in the YouTube, not YouTube, in Facebook, you have friends and friends of friends. So all these connections would make you someone who would make decisions. And your decisions are shared by so many people, and those decisions are shared by so many people. And there is something called, which people are trying to find out in social media, something called influencers. An influencer is a person who makes a first comment and whose comment is repeated by many others. So influence is one of the things that social media is trying to find out, and that is also done with the help of graph generators. So graph generators can be used in various areas. So it is only a technology. It is just like a tool that you use, and it can be used in chemistry also. And this was actually an animation which I was able to play, and I was able to play, but that is showing hydrogen and the network that is coming out. Well, why do we need this kind of tools for doing research? Because if you look at all the possible elements like magnesium, iron, platinum, all other elements, you find that there are about 10 to 20 possible material combinations that you need to explore. And the Milky Way galaxy has only 10 raised to 11 or 10 raised to 10 or 10 raised to 9 stars in it. So it is much larger than the number of stars you have in the Milky Way galaxy. That is a number of combinations you need to try, which means that it will take millions of years, even the whole lifespan of a civilization, for doing this kind of analysis, which is impossible. And people thought that this is an impossible task, but today AI machines are able to handle all these things. For example, it can handle 1 million candidates. It can scan through 1 million candidates in about an hour, or that will reduce millions of years to a few years. Right. So that is a kind of speed, and accuracy also is very important, which AI models are able to cover. Well, key matrices are, as I mentioned before, their capacity, kinetics and stability, which are three key matrices that we consider here. So for that we use a neural network. Neural network is just like the neurons in our brain. Neurons are what our brain uses to process data, and whatever comes into through our sense organs, 5 sense organs, goes through these neurons and are processed to make intelligent decisions. Likewise, this is also a neural network structure. I don't know whether it doesn't in the morning I mentioned this, but this is a structure of a neural network which takes inputs at one end and produces output at the other end. So for example, if you give inputs as the features of a cat and a dog and some other animal, it will be able to say which is which. For example, I mentioned about the Google is able to tag your names. So that it does with the help of a neural network. So neural networks are the most oldest and also very powerful tools. Well, data requirements, it requires large amounts of data. Again, 10⁻³ to 10⁻⁴. Labeled data. Labeled data means you need to say this is a picture and this belongs to this person. This is a picture, this belongs to that person. This is a picture that belongs to other person. So you need to have lot of data, and as the number of photos in your Google images, Google photos increases, the accuracy with which it is able to predict would also increase. So I mentioned about DFT calculation. DFT calculations are very useful in doing this kind of analysis. For getting these parameters, labeled parameters extracted from it. Well, then there is a loss function. Loss function is what you want to minimize. You want to minimize the error. So error is what I say that this is person A, but it is person B. So how many times it makes a mistake? You want to reduce that mistake. So that is usually done with a method called mean square error reduction. And mean square error is you know what mean is. Mean the taking the mean of the errors and you add them up, and you try to minimize it. So reducing that error would make it ideal for doing this kind of analysis, especially for continuous properties in chemicals. So you can say what concentration would be best for maximizing the yield. You want to get maximum yield from it, so what concentrations this should be mixed. Those things can be actually predicted. Well, there is a pitfall here. If your data size is small, then you will have overfitting. Overfitting means on the training data means on the label data, it will give good accuracy in prediction, but when you do it for a testing, you will find that it degrades in its value. So that is one of the problems with small data sets, which is the reason why everybody is looking for data. And for ChatGPT and other things, you are using all the data that is available in the internet, which is almost equal to the whole data that humans have collected over 6 sessions. Okay, this is just an example. This is a 3-layer name which I showed, and that is a prediction accuracy. In the prediction accuracy, you can see that there are 2 axes. One is the predicted DFT energy on the lower axis, and that is the prediction by the particular ANN. You can see that both of them are agreeing very much, which is the reason why you find that it is in a straight line. See, I have no time to go through the details, but I am just giving a flavor of it. If you are interested in this area, this is the area in which we work, so you can always contact us and give the email ID at the end. Well, then came convolutional neural networks. Convolutional neural networks is something that we call the deep learning methods. Deep learning, the ANNs or the earlier types of networks. Convolutional networks are able to extract the parameters themselves. In the case of ANN, as I showed, you have the feature engineering that has to be done, which decides what are the inputs that are going in. Here you just say, I'm giving this picture of that person, I'm giving this picture of that person, you find out how to differentiate them. So it will do the feature engineering, it will extract the parameters and do the analysis. So this is one example in which this has been experimented, and the input were, in fact, electron density functions. So that is what the DFT gives. So the DFT inputs are given to the CNN model, and it was able to predict the output, predict accurately how the crystal structure would be. So, so what it learns is that it learns how the connections, for example, a crystal structure, whether it's a rhombic kind of structure that you're getting, or whether it's a this FCC kind of crystal that you are getting, all these things it learns from the material's property. So it looks at the atom and find out that this has so many free electrons, what kind of, whether it be covalent bond or whether it be an ionic bond or what kind of bonds it will have. All these things it will be able to learn from the data set, and those label patterns would be used for understanding the local bindings between the patterns that it finds. So this has been very accurately used for identifying stable kind of hydrides, because most of the hydrides, once you develop it, you find that it evaporates off or it degrades off, it gets contaminated easily, those can't be used. So, but this AI tools were able to predict which are stable, which would be less stable, just based on the DFT theory. Challenges? Well, one of the challenges with this kind of convolution neural network is that it uses fixed grid sizes. You are looking at a certain area, you are looking at just an area, and it is repeating itself, it may get confused by that. But in crystals, everything is repeating. You can grow the crystal to larger and larger size just by adding on it. So that kind of things would produce a lot of issues here. And if you change the number of atoms, you can do the training for 3 atoms, 4 atoms, 5 atoms like that. And if you randomly change the number of atoms, then also it will produce problems. So these are the limitations found with CNN models. So the alternative is graph neural networks, which I mentioned, are found to be one of the most reliable, but that's other than, I'll come to that, transformers. What graphs do is that you have a neural structure like this, you will convert it into a graph structure like that. So you consider what the bond lengths are, what the angles between those bonds are, what elements are coming in, all those things you code it and put it as a graph. Graph is just like that. It's very much similar to that. And what is critical about the graph is that whatever happens with that bond length and all other things will depend upon its neighbors. So graph, as I mentioned, see, an influencer is able to influence you. Your friends are influencers because they will tell you something and you obey that. Your parents are your influencers because your parents tell you something and you do that. So this kind of influencers are what are the vehicles close to you, and that will decide what the bond length should be and what the connection should be, what structure it would have. All these things can be expressed in terms of the neighbors. So the neighbors are the DCC factors. So what we call it is the message passing. So it passes messages between the molecules or atoms, and that will decide where this should come into. And I mentioned about protein structure. Protein structure also does something similar. When a protein, protein structures are made of amino acids which are able to have electronegativity or electropositivity, and that is what binds them together. So this kind of electron activities can be studied with DFT theory, and that is how it can become very popular. And messages are passed between two molecules saying that I will come near you, and it will say, oh, you come near me, and that way it bonds together and makes a structure. So that is how proteins are able to make unique structures. Or even molecules, materials are able to make unique structures which are good for absorbing hydrogen, and that is what our goal is. So that is based on neighbors. So neighbors decide the thing. And okay, predicting dehydrogenation. Dehydrogenation is a speed with which hydrogen can be released. So this could be easily predicted by the graph method, showing that it is capable of doing what it is supposed to do. This is just an illustration where the graph, these are all atoms, and I mentioned about chemists doing chemistry without going to the lab. They use this kind of simulations. Well, this is also an animation. I'm not going into it. You can see there is an atom called A there. Its position is decided by all the atoms around it, and those connections that are showing are the influences. So they will influence, and they are in different layers. So an atom that is far off from this atom won't be able to do that. So there is something called a layer structure in which these atoms are in the crystal. So what influences it will decide what kind of structure it will have. So this is how the graph network works. Well, This is an example where graphs have proved to be very useful, where M3GNet is the model that they use. So there is a graph network that is able to predict 12 new titanium aluminum hydrides compositions, and 3 synthesized and 2 exceeded DOE targets. So that is the kind of output it is able to give. It's able to understand the complex system so well that even more, much beyond what was expected, it was able to do. That is the structure of the visual identity. Okay. Then there is attention mechanism. Attention mechanism is what drives ChatGPT and all other large language models. Attention mechanism means you're focusing on what is important. Learn which atomic interactions matter most. So you find that there is a particular, for example, titanium. Titanium, when you introduce it to magnesium hydrides, you find that its absorption ability increases, which means that titanium, what is it doing there? So it's an important element that decides how the particular structure would behave in a particular situation. So all these things are decisive factors, and you can identify what is the criteria that enables titanium to behave like that, and that is how they are able to introduce new materials. So that answers your question. So you ask how based on one element you are able to do it. For example, platinum, instead of platinum, how would the machine know that iron can be used in its place? So it knows because it learns the interactions, and it finds that if you put if you replace this platinum with this particular iron and some other compound, it produces the same kind of interaction, and that can be used to replace platinum, which is a very expensive material, with much less expensive properties. So those are possible with attention mechanism. And well, transformer GNN is what graph neural networks. That's a hybrid for mostly used for metal organic frameworks, which are very good for hydrogen storage, for solid state hydrogen. Linker function groups are actually about the bones itself. I said what links them together. So when an atom comes here and another atom sits here, what is the linkage between them? Those can be predicted by graph neural networks, just by finding out how much influential those molecules are. Multicast learning in hydrogen storage. Because we are working with machines, they are able to learn multiple tasks simultaneously and reduce the error for them. So there are a lot of different methods that are being used. Architecture is usually called encoders. Encoders are devices which are able to analyze and learn how things come together and behave together. For example, when you are alone, the behavior you show is totally different from the behavior when you are in a group. So that kind of differences can be learned, and those are actually encoded, and that can be reproduced for task specific experimentation. So you need only 30% less experimentation for when you use this kind of thing. So you save a lot of time, lot of energy and money. Well, physics-inspired informed neural networks, I mentioned about it. Physics-informed neural networks use thermodynamic laws as a loss function. Loss function, I mentioned about mean square as a loss function, which is what you try to reduce the error. But here you can use thermodynamic laws as a loss function, so that your machine will learn based on thermodynamic laws. In NLP, natural language processing, which is used in ChatGPT, the laws of grammar is used. If you speak in English, it will be able to do it well. If you speak in some other language, unless it learns the language and the grammar it uses, it won't be able to do an equal performance. So this is the kind of learning that goes in, and thermodynamic laws are being used here. Okay. So advantage is better exploration of novel composition, because you are using the laws of physics. You know that hydrogen can only combine with some molecule which makes the oxygen structure possible. So those kind of things can be done. And I mentioned earlier, this is it could predict the phase diagram. Phase diagram is a phase changes that happens in the particular material when it starts absorbing, when it starts liberating hydrogen. Those things can be. Then there are the generative models. I mentioned about generative models also before, and they are very much used in designing this metal organic frameworks. There is something called variation autoencoders. Autoencoders are able to take an image, reduce it into a small dimension, higher dimension, but a small latent space, and then reconstruct the image. But there it is those points that decide what the output would be. But you can use probability instead of these points, and that is what makes it a variation encoder. And variation encoders are able to predict weather values. Because you know what is the probability for it to rain today, you will be able to say on another day what is the probability for it to rain by looking at the sky and the wind and the humidity and all those parameters. So like that, we can have a probability distribution, and based on probability, we will be able to predict if this material works good for you, these other materials are likely to work good for you. So that kind of predictions are possible with variation encoders, and that is another area in this. Well, they will be able to tell you what kind of 3D structures and coordinates and lattice parameters those vehicles would have, so that we need not have to analyze them later. We will be able to directly go and use them. Success, I mentioned about this, the 9501, which was able to give 9.8 vapor storage capacity, which is much higher than what even liquidizing or pressurized hydrogen storage could do. Active learning, again, we have mentioned this, very test retrain. So you go, pick up the data, train on that, make a prediction on the entire data set, find out where it fails, pick up those data, train on that. Together you find out what is the best training data for them. So self-learning labs are going to work like that. It will take all the elements, it will work combinations of that. It checks whether this has been published somewhere. If somebody has found this good, it will tag it as a possible combination. And likewise, it will learn automatically learn instead of you going to the literature survey process, doing all the analysis and doing the thing. So this autonomous lab, all labs are that the name comes from the local industry. Auto-driving, okay. Autonomous labs. Autonomous labs are actually using it. They are 90%, they are unique. Very few experiments, just to confirmatory experiments. It is able to predict with 90% or 95% accuracy what the output would be, and you need only those experiments to validate that the machine has given you the right answer. Uncertainty quantification is another very important thing. You need to know how much uncertainty is there in the prediction. So with every prediction, it will give you some output which says what is the probability that this is going to work. And there are different methods that are used. Monte Carlo method is one of the most common method that is used from a long time. Even in undoing and all those things, we have been using Monte Carlo simulations, and that is able to find out dropouts which are to be thrown out. So it will say, oh, these are not prepared, these are not good, and it will find the computer. So it will be able to flag them as not good, and reduce the failing chances by 60% if you use Monte Carlo, for example, uncertainty quantification. Benchmarking, of course, this benchmarking is done by minimizing the mean absolute error by the energy values. Those who are familiar with this material science background, they know what these energy values mean, the band gap energy and all those things that you talk. So here also, the energy values that the thing predicts, the compound in the molecular compounds should be less than 0.1 electron volt. That is one condition you should say. Then the significant accuracy should be more than 90%. And there are different ways in which this can be done for various materials, different materials. And there is something called a leaderboard. Leaderboard is it's a common platform where you can publish you can say this is the result I get when you do this, and this is the result. Everybody comes and says, they will say how they did it, but they say that this compound is able to do this, and it will be automatically ranked. So you know who is on the top, which material is able to give the maximum hydrogen absorption or maximum hydrogen disposal. All these things can be done much faster. Well, GPUs or hardware accelerators are being used. GPUs are able to do about 10⁶ predictions per day on A100 is a GPU. Maybe you are not familiar with that, but GPUs are used for high performance computing. It is able to do about 10⁶ predictions per day. And quantum machine learning is coming as a future comes for electronic structure. Okay. Diffusion models for materials, foundation models, hybrid, GPGA, which is something that is coming up for this. These are the future expectations. So, the investor, we have a company which is the first one in Kerala for doing hydrogen, and we are building a hydrogen house now in Tiruvalla, which is going to be, the company is called Decarbon, and we'll be producing hydrogen as an alternative for, and giving training also for those varieties. So that is my email ID. You can contact Gigapol also, who is also one of our faculty members there at ASWB. That's all. Thank you. So I hope I finished the time.
1 minute of discussion.
Yes.
If you have any queries, you can interact with them as well.
You can ask in Malayalam also. Both of you can understand Malayalam. Because this is being recorded, otherwise I would have also preferred to speak in Malayalam. Yes. ChatGPT can I speak in Malayalam or can I speak in English? Should I speak in English? This is where this goes in Hokkaido. Okay, so I answer in English. So your question is about ChatGPT, and you are asking how ChatGPT is able to read literature that is not accessible without a publication. ChatGPT, the one thing you need to be very careful about using these large language models like ChatGPT is that it is designed to give you only 80% accuracy, which means that 20% of the things it says is just fake. Why it is fake? Because it is designed to be fake. Why it should be fake? Because then only creativity can come. To be creative, to be artistic, you need not see. If I take a photo and draw it like that, you won't call it art. You call this art because it's not like a photo. It is much deeper than that. There is a lot of things unrealistic in it. So that has been incorporated in many of these large language models, especially ChatGPT. But there are alternatives, like for example, Perplexity or DeepSeek. All these things will give you much more reliable answers for your questions. Your questions about reading the data. Whatever is available on the internet as public data is usually read. And if you ask it a question about something that is confidential or classified, it will tell you that I have no access to it. So that is the general rule. But whether somebody can cheat you is totally different. Yes. See, that's the problem. Unless you have all the data that you need to describe the system, you will not be able to get reliable answers. അതിന് ഒരു എക്സാമ്പിൾ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ മെഡിസിൻ. നമ്മൾ കഴിക്കുന്ന പല മെഡിസിനും നമുക്ക് കൊള്ളാവുന്നതല്ല. കാരണം അത് സായിപ്പിനെ പരീക്ഷിച്ചതാണ്. പിന്നെ പരീക്ഷിക്കാൻ വേണ്ടി സായിപ്പിനെ പരീക്ഷിച്ചിട്ട് അവർ തരുന്ന സാധനം അത് സായിപ്പിനെ വെച്ച് ഒന്ന് വെയിറ്റ് കഴിഞ്ഞാൽ നമുക്ക് ഇല്ലാത്ത അസുഖമുണ്ട്. സോ ദിസ് ഈസ് വാട്ട് ഈസ് ഹാപ്പനിങ്. ദാറ്റ് ഈസ് വൈ ഗിനി പിഗിന്റെ അതേ അവസ്ഥയാണ്. അപ്പം ദാറ്റ് ഷുഡ് നോട്ട് ബി അലൗഡ്. അതുകൊണ്ടാണ് ഡേറ്റ ഷുഡ് ബി പബ്ലിക്. നമ്മുടെ ഒരു ബേസിക് നേച്ചർ, ഹ്യൂമൻ നേച്ചർ ഇസ് ടു refuse. We say that it should not be public. And believe me, there is nothing that is not known about any person anywhere. Your mobile phone, which is sitting idle near you, is recording all your conversation, is taking note of all your locations. It is taking note. It knows. Google now knows that you are sitting here and attending this meeting. Because Google knows who are there and what is happening here. If you look at the internet and you will find that this is a AICT program that is going on here and you are attending that. So all these things are known. And even if you switch off your mobile, why the mobile does not allow you to remove the batteries? Have you thought about that? See, earlier old mobiles had a battery which you could replace. Nowadays you can't do that. Because even when it is switched off, it is recording. And your movement is completely recorded. So there is nothing like privacy. Privacy is just a fake thing that you are thinking. So there is no privacy, and that is what is assured. The other thing they assure is that we won't disclose it to anybody, but we will know. We will know, but we won't disclose it to a third party. So that is the only assurance all these people are giving. So there is nothing like privacy, and the problem with us is, that is what I wanted to say. When COVID came, we refused to share our data with others. We said, oh, this is our data. What is the value? No value. But this is our data, we won't share. What happens is that when COVID vaccine is developed, if it is not suitable for our body, you are in trouble. And you'll find that more people here are affected by COVID vaccination than in other parts of the country or other parts of the world. It happened in US and other places. Luckily, we were not using the kind of vaccine, RNA vaccine that they were using, which is much more riskier. So, well, that is it. So, this is our question. So, data, if you have only 5% data, your 95% chance is that you will get a wrong result. You won't be able to reproduce the 95% results that others were able to do. Which is the reason why all these for learning systems and other things are being done.
So we elaborate on the functioning of the state, the state, the carbon, what is the state and the article.
Oh, okay. This one. This is actually, you know, Father Abraham Mamutin? Okay, so he is a visionary. He is the person who started MacFast. He is the person who constructed this. There is a church in Tiruvalla, the Kudarapalli. He is a person who started Radio MacFast and all this. So he is a visionary. He came up with this idea about a year ago, and he had the idea that we should go for green energy and hydrogen is a solution. At that time, even I didn't believe that this is going to happen. But sooner we found that this is actually happening. And at that time, he had a consultation with a company in Germany who is producing hydrogen. And their product has been imported here. And that is the one which is the working model that is available in Tiruvalla now. And he is building a bigger one which would power the entire house. This is just a demonstration model which was it was costing about 5 lakhs or something like that, which was just a demonstration model which is portable, so that it can be taken to different places and demonstrated. So this is an area of research that we are also interested in, because this is the promising area, and that is what Decarbon is. It is a registered company which is focusing on research, development and distribution of green hydrogen.
So the website said that it is
Yes. Yeah. Decarbonized. This one, the researcher significance that it is the first one here. First one is always going to be defective. You have to improve on it. But you need to start from zero. Then only you can start counting. So this is the zero. Just drawing a zero here, and that is the carbon. So future is yours. Yes, yes. We are using solar cell for the production of hydrogen. We are using a fuel cell for converting, and they are showing demonstrating the carbon without.
Are you funding the state of government? But we are
This is all running on interest of the people. But see, there is some level of threshold to which you have to go. But if you believe it, then you completely believe it, then the family everything. So that growth has to happen. So you have to start somewhere. So this is how it's possible to do. But we are going to do it. It's possible to do it. It will be okay. And over that, you are actually supposed to make that. Yes. See, production cost for hydrogen development is the solar panel that you need for converting solar energy into electricity. You need electricity because you need to produce hydrogen by electrolysis, and you want to make it free because if you use the consumer electricity, then it will be much expensive than the energy that it can produce. So using solar energy, you develop hydrogen. You store it at a certain pressure. You cannot keep it at high pressure because of the risks that are involved. So you keep it at a certain pressure, and it is just like a battery that is charged. You can use a fuel cell for converting it into electricity. So there is no additional cost once you make the initial investment, just like the solar panels. The initial investment is your investment after 6 months. You need to add water, that's all. But we have plenty of money. No. Okay. Should I switch it off?
Yeah.
Yes.
there is one more.
Yes. Okay, come here. Come here. Very easy. But oxygen is very processed, you know. You can't take oxygen directly. You have to mix it with the air and use it. Okay.